Salam Alaikum wa rahmatullahi wa barakatuh. So today we're going to be working on determining the electron configuration of chlorine atom. So the first thing you have to do anytime you're given an electron configuration question is to determine the number of electrons of the atom. Hence, we're supposed to determine the number of electrons of chlorine. But before we do that, I want to show you guys a trick in order for you never to get confused. So this works for atoms. Whenever you're given an atom, the atomic number of the atom is always equal to the number of protons. And I mean atom in the case that the in the case of chlorine, right? So the atomic number of chlorine is always going to equal the proton number. And in the case of atom as well, the proton number is always going to equal the number of electrons. So the atomic number of chlorine is 17, and that's going to equal the number of protons of chlorine is 17. Hence, that equals the number of electrons for chlorine to be 17. So the atomic number is equal to the number of electrons, which is 17. Now, the next thing you have to do is to fill up the number of electrons in this energy level, starting from the lowest, which is 1s, up until we use up all of the 17 electrons by filling in each one of the orbitals in this diagram with two electrons. So this has three orbitals. So you have the 1s, we have the 2s, then we have the 2p, then we have the 3s, and then we have the 3p, and then we have the 4s, but I didn't draw it in this particular case. So we're going to start filling. We're going to fill two electrons only in each one of them. So we have 1, 2. So we've filled two electrons, remaining 15 electrons. We have 3, we've got 4, we've got 5, 6, 7, 8, 9, 10. If you are observant, you're going to see that I filled in each one of the orbitals before I filled it twice. That is because you need to fill each orbital with one electron before you fill the second one, because you know electrons are negatively charged, and negatively charged or like charges repel each other. So hence you cannot put two electrons in the same orbital. You've got to fill all of the orbitals first to avoid energy destabilization before you now add the extra electron. So before you pair up, you've got to fill each one of the orbitals separately. That rule is called Hund's rule. So now we filled 10 of the 17, so we've got 7 left. So you have 11, you've got 12, you've got 13, 14, 15. We have two electrons left, so we're going to put 16, I'm going to put 17. So what you have here is 1s2, 2s2, 2p6, 3s2, and then you've got 3p5. So when we write all of this down, we know that the electron configuration for chlorine is going to be all of this information here, which is 1s2, 2s2, 2p6, 3s2, and then 3p5. So all of this is correct. Now, in order for you to check that your answer is correct, you have to make sure that you follow the energy level order, starting from 1s to wherever you're filling it up to. And then you also have to count the number of electrons. So we've got 2 electrons plus 2 electrons, 4. 4 plus 6 electrons, 10. 10 plus 2 electrons, 12. And 12 plus 5 electrons, 17. So that matches up to the number of electron, which is 17, making our answer to be correct. And the electron configuration of chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. And I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.